So this is the third Nansen Legacy cruise that I've been joining in person. You can see me here. This is on the JC21 cruise. It was last July. So I mean, I joined as more of a lab potato on that cruise. So I'm very aware of how much work you already have on the cruises and how much work this is extra. So we'll try and make it as simple as possible. Hopefully me being there on the cruise as well will make it easy for everyone. And we'll talk today about why we're doing what we're doing and how we're going to do it as well. Let's change my screen. So what we're aiming to do in logging all our metadata is to provide an overview of all the data that are collected. And those data are also available after the cruise via SIOS. So if I open this up, hopefully you can see this. Sometimes takes a moment to load, but what we're going to see is an overview of not just a single cruise, but all the Nansen Legacy cruises in one place. I don't know why this is taking quite so long. We will go back and I will stay on here and we can go back to it later if necessary. But basically, what that shows is a searchable catalogue of all the data that we've collected. And you can filter by things like the type of sample that you've collected, or the PI, or the station that you've visited. And this serves a couple of purposes. Firstly, for us on the cruise, we can see and document everything that we've done. For people who haven't attended the cruise, or people who are maybe not even part of a project, they can see which data have been collected in order to plan future cruises. And also, let's say they're interested in working with some data and the data aren't published yet, they can go and find who has recorded those data, who's responsible for those data, and who can get in contact with who to get in contact with to get those data. Since this is a big multidisciplinary project, this is really important for us. We need to keep the biologists up to date with what the oceanographers are doing and what the meteorologists up to date with what anyone else is doing, and all different combinations. We label all physical samples with labels I'll show you later, and we log that electronically. So the link above is the electronic log, but we also label everything. And this interconnectivity between the two is also important. A lot of research institutions, the fridges and freezers are full of old samples that no one really knows what they are anymore. If you find a sample, an Nansen Legacy sample, in theory, it should have a label on it with a little data matrix, like a QR code. Someone can scan that, go to the link above and find that sample and be able to identify exactly what it is. We also log any samples which don't have a physical sample, but for example, something that you dispose of on board or something that isn't ever a real physical thing in the first place. And perhaps one thing I haven't mentioned enough in previous presentations when I've done this is that this should make it easier to publish your data fairly in line with the fair data management principles later, because the logging system that we are using is compliant and already considers some different standards. So we consider the Darwin Core terms and we consider the CF standard names in some cases too. This is an example of a log that I filled in. So it's just an Excel file. There's a couple of sheets. This is a data sheet. And each row on here is one sample. So this is some data I collected last July. This is chlorophyll A data. Each individual row has its own ID. This is a unique ID. It's universally unique. I'll go back onto that on the next slide. But we also have this hierarchical system. So you have each sample has an event ID. This is the ID of a sample that I've assigned. And then we have the parent ID. And this is the ID of a parent. So since this is a chlorophyll A sample, the ID is the event ID is this ID of a chlorophyll sample. The parent event ID, I think, is probably the ID of a Niskin bottle that someone else has logged. So we use universally unique IDs, or UUIDs. These are 32-digit hex numbers, so that means they're 32 digits long, and a hex number is the digits 0 to 9 and also the first 6 letters of the alphabet A to F, so 16 characters to choose from. And they've got a very low chance of collision, which is why we use them. You can also represent this as a data matrix. So a data matrix, when you scan it, is just you can recover the text that you have entered. So you can also create a matrix that is based on this text, and when you scan this, you can recover this text. So then we assign this data matrix to all our physical samples. The hierarchy is one thing that a lot of people, I get a lot of questions about, so we'll take a bit of time on this. So imagine we're at a certain station. We have a couple of sampling activities which are at the top of the pyramid. Now, these can be things like a CTD or a box core. It could be a trawl, a multinet, whatever. Below that, you might have some extra gear that are bolted onto that. So if you have a CTD, you might have Niskin bottles. If the activity is an ice station, you might have some ice cores. I don't think that will be applicable in our case. And then you have samples. So this could be your water samples. It could be fish. It could be whatever else you're working with, the chlorophyll samples from a previous stage. And then you might have some subsamples below this, and this can go as far down as you need to go. So in each case, you take a UUID of your sample, and you also take the UUID of the parent and log that as your parent ID. A specific example, if we have a trawl at a certain station, maybe we have 3 fish, and then we divide one of those fish into some different pieces. We have a liver and the spleen, so we log them, each with their own ID, and we log the fish with the ID as the parents. Another example, maybe we have a couple of different activities at a station. We have a CTD and an MSS. It's quite typical then to have your Niskin bottles bolted to the CTD, which would be the children of the CTD. You might have an LADCP and master and slave as well. Then the water that you take from the bottles would be the children of that Niskin bottle. We'll revisit this in a bit as well. So the rest of this presentation will go through exactly what you need to do on this cruise. And again, I will be on the cruise as well, so I'm there to help. So what I ask people to do before the cruise, is, if possible, is to create these sample logs or create these Excel files. The reason I ask people to do this is that firstly, you're very busy on the cruise, and if there's one less thing to do while you're on the cruise, it's good to try and fix things before. Also, I've found it quite useful when I've been doing this, but in filling out what I can on these logs, it's already given me an idea of what I need to do at each station, so it can be good for planning as well. The sample log generator looks like this. I'll put a link down to this via email afterwards, so you don't have to worry about this link on top right now. You select different boxes for certain fields that are required for every sample, some things that are recommended, and you can scroll way down on this, and there's loads of different fields to choose from. Each of these fields then becomes a column in your Excel file. When you hover over one of these fields, you'll see on the right-hand side some information about that field. So you have some validation info, which is tells you how to fill in that information. And we also have, if this is a Darwin Core term, which this parent event ID is, some the text provided by the Darwin Core standard. Every time I get some data from a cruise, we have someone who has used an old log sheet from a previous cruise. Please don't do this. Create a new log for each cruise. There's a good reason for this. Firstly, if you copy and paste things around in Excel, this can corrupt the file. And also, we update this logging system quite regularly, especially things where we have drop-down lists. We add new options depending on what you've told me is necessary. And if you don't have the latest version of the file, you don't have that option in your drop-down list. There's always a case where you can't do this before the cruise. Maybe you need to create an extra log. So that's possible to do on board as well. So when we're on board, we have the logging system is stored as a virtual machine. Basically, all that means is that if you plug in your computer to the network with a Ethernet cable, and that's a good point actually, if you have an Ethernet cable, bring it with you. There's usually a few on board, but it's good to have an extra one in case. That'll be useful for a whole range of different things if you need to use the internet as well. When you're plugged in, you can go to a certain IP address. I think this will be the IP address, but we haven't run this on GeoSARS before, so I need to set this up the day before the cruise starts. And you'll get to a home page that looks like this, and this should have everything you will need to use on the cruise. This is actually a slightly older version, but it's more or less the same. So you can get to the template generator here. Once you've generated a file, it looks a little bit like this. We have a hidden third row, which you shouldn't touch. And each of these responds to a Darwin Core term in some cases, or whatever other term. And these are the terms that I use later to read in these logs into a single database. So if you have misspelled one of these terms, my code won't recognize the column. You can also use that to your benefit. Let's say you want to log some data alongside this that shouldn't be in the metadata catalog. We're in the business here of logging metadata, not the data themselves. You publish your data separately later. Or maybe you have some extra stuff you want to log that's not really suitable for this logging system. You can then just create an extra column, leave this third row blank, and I won't check it. As well as the data sheet, you also have this metadata sheet. This metadata sheet describes the file as a whole. So in the data sheet, you have one row per sample. This metadata sheet describes all of the samples. So things like data, a title and abstract, who's responsible, who's filled in the sheet. Each time you hover over one of the, or select one of the cells, you'll have the notes. These were the notes that were on the right-hand side of the template generator, so you can read those. You can drag it to one side if they get in your way. Just some notes on what to fill in. The abstract should be like the abstract in a paper. If you do this well, you can use the same abstract when you publish your data set. If you write something brief, then you probably need to write another abstract again later. Some information about the APIs. Good practice is to separate this with different people with semicolons. I try not to use commas because if we're converting things to CSV later, then the comma is a delimiter, so we need to use something different. So typically use semicolons to separate people. And in this case, so I have Libby and Marit as APIs on this sheet. I've put both of their email addresses, both of their institutions, both of their addresses. They're at different institutions, but even if they were at the same institution, I would write the PI institution twice. And that's for the sake of ambiguity. If I was to write just IMR, and if they were both at IMR, it wouldn't be clear to me whether Marit was at IMR or whether this has only been written for the first provider. So it's to remove all ambiguity. The datasheet. This is what I filled in before the last cruise. So this is an idea of what you can perhaps do to save yourself time. I already know which stations I'm going to visit. I can write all that down and the depths I want to sample. I used the event remarks and description columns to provide me with some help on what I needed to do, some reminders of what will be collected at each place. And this will then also be useful for the data user later. I know who's going to be recording the data. I know who the PI is going to be. I can fill all that in advance. And I know where the samples are going to be stored later, the sample location. So I can do all of that before I start the cruise. There's obviously a few things that you can't fill in advance. The time, the coordinates, the IDs probably. That's but at least you've saved yourself some time. Just to go over some different columns that are a bit more important and we sometimes see mistakes on. The sample type column. This is from a drop-down list. So ideally, this should refer to a simple thing, a physical thing, what the type of sample is. This hasn't really been used very consistently throughout the project for a number of reasons. We've added things that are more about the method that have been added. So you can see in this case, microbial diversity isn't really a sample type. So where possible, use a sample type, but it's important to also be consistent what people have done in previous cruises. So we have to be aware of that. If you do see that something's been done wrong in a previous cruise, or you want to update something from a previous cruise, just let me know. I can also update the logs in hindsight. The sampling protocols. In Nansen Legacy, we have published sampling protocols documents that describe how we collect our data. These are really important because it means that if I go on one cruise and someone else goes on a different cruise, and we both collect the same data, we know that those data have been collected in exactly the same way because we've both followed the same instructions. And just this should also refer to the version and the section. This is a long document, so provide as much information to the user as possible. The rest of this should be quicker, don't worry. Print the labels next for all the physical samples. You can do this from this homepage again. We have large labels, medium labels, and small labels. On the right, you can see these labels coming out of the printer. These are the medium labels. The larger ones are bigger, and the ones on the left-hand side are these small ones. So these small ones are only the data matrix. The others, you have some lines where you can fill in some text however you want to identify that sample. These medium labels are customized and are good down to -80 and have been tested to that. It also means they're a bit more expensive. So if in doubt, use the large ones or the small ones if you don't have space. If you need the medium ones, use those. You have an interface to print these labels. It looks like this. You have a couple of different lines. It'll take you directly to the IP. This will be filled in automatically. You don't have to worry about this. Some errors we sometimes see is that it's always the case that you need to sometimes reprint labels. So if you reprint a label, make sure you rescan it too. And also, when you hit print here, all this information on these 4 lines will be saved for the next label you print. So make sure you're updating it if you need to update it. Once you've printed off your label, you need to scan that label to get it into your electronic log. This is quite simple. There'll be a lot of different USB scanners that I'll be bringing with me. You plug them into your USB socket like you would your mouse or anything similar. Select the cell you want to use and just pull the trigger. We also log our virtual samples. So what you will need is an ID for each of those. So we have a UUID generator on board. you can go to this, copy and paste the IDs, and take as many as you need. There's only 4 here. There's actually a new system on board now where you can specify how many you need. So if you're someone who's using 1,000 UUIDs for some reason, you can just type in 1,000 and get them back. So you don't have to click get new every time. And then you need to fill in the rest of your metadata in your electronic log. So this can be things like the date, the latitude, the sample type, whatever else. But importantly, and perhaps most importantly, is the parent event ID. So again, we need to go back to what the hierarchy is. So consider what hierarchy you're using before the cruise, what the parent will be of the samples you're using, and make sure you know where to get those from, the IDs for those from. Obviously, I'll be on the cruise, so you can just ask when I'm there as well. So just an example, the activities and the Niskin bottles, they will be logged semi-automatically. I will be doing this now for this cruise. I'll show you how they work briefly, but you will be able to create your own versions using some interface and then copy and paste the ID from that. So this is an important point as well. Don't include the parents in your own log. Every sample should only be logged once, and that includes the activities if you think of those as samples as well. That's not just logged once per sheet, that's logged once for the whole cruise. So the activity log generator is here. So if you need to find the ID of the net or the trawl that you have taken a sample from, you click on that. There's a button at the top. You hit that one. It pulls data from the TOC logger, which is the cruise logger that IMR have. This ensures that we in Nansen Legacy are using the same IDs to refer to activities as IMR, which is useful if we need to communicate with them. Then it'll create something like this. So you just copy the ID from this column and paste it into your parent event ID column. Some people need to know the CTD number as well. That's in the local station ID column. The TOC logger knows like this, looks like this. Sometimes you need to know, sometimes it's difficult to know which activity is which in the log. If you have 2 activities that are similar, close together in time, there are ways to make this simpler for people. So if you're sat with the instrument crew when they're starting an activity, they hit this new activity button and they have some interface that looks like this, and they can put some comments in here. If you're sat with them and you want them to write something, you can write this here and it will be used to populate the event remarks column in the activity log. Different cruise leaders and different people have used this for all different types of things. One idea could be to use the people who are involved with a certain activity. For example, some people like to refer to different standards. If you've got different standards for the CTD deployments, for example, whatever you want to use that for. The Niskin log works similarly. You just generate this. This takes the information from the bottle files and also the TOC logger and dumps it to something like this. So in this case, you have 2 ID columns. You have the ID of the bottle in the event ID, and you have the event of the ID of the CTD as the parent of that. So if you are taking a water sample and you're logging that water sample, you come and take the event ID and paste that into your parent event ID column in your own file. After the cruise, well, before the end of the cruise, we have an onboard checker that checks for things that I can't check myself, or not efficiently anyway. So this is available here. And you can run this file iteratively through every log that you're creating until it passes. So this will be used to identify if you've picked a sample type that isn't from a drop-down list, for example, if your date is in a format that it can't recognize, if your ID isn't in a format it can't recognize, different things. It will identify if you've used the same ID twice in the same file, because they should be unique. And it will identify if you've missed a column that you should be including. Something it doesn't identify firstly if you have made some copy and paste errors. If you've copied the wrong ID across, it can't do that. So you have to be extra careful for that. Any mismatches between the physical samples and the sample log. So again, make sure that you're rescanning all your labels. And the other thing it doesn't check for at the moment, at least in this version 1, is that if you have included an ID and someone else has logged the same sample with the same ID, or even even worse, a different sample with the same ID, it can't check for that. It checks each sheet as a standalone item. So it looks like this. You just choose a file, hit submit. Hopefully you'll get some green text that tells you that it's been done. If not, you will get some red text. It will tell you exactly what the errors are and you can fix them. If you don't understand what the errors are, come to me. And finally, and just on time for 11 o'clock, we can deposit data in the cruise folder. We'll be using this for quite a lot of different things. I'll make some metadata or sample logs folder or something similar. It'd be really good if you can create a subfolder within that with your own name or the group that you've been working with, all of your names, and then dump all of your logs in there. And that's everything. Yep, we'll take some questions, just 19 days until the rest of the cruise. The key points: create what you can in advance, new files for new cruises, and ask me if you have any questions. And I'll take any questions now, and I will also stop recording.